Good morning, children. In the previous video, I had explained what is motion and two terms related to describing motion. We had understood distance and displacement. I gave you a fairly good idea about that they are not equal, they are not one and the same, but they are totally different physical quantities which are utilized in describing any object in motion. So today we continue further. On page number 100, you will find that there are certain blue questions which are given. I'll discuss it out. You'll write it down in your book. The first question says an object has moved through a distance. Can it have zero displacement? Means an object has moved a distance. Can it have zero displacement? First question is that. Can it have? Well, it can have. If yes, then support your answer with an example. So this in the first video itself, when I was explaining, if you remember, I told you that if an object is moving in a circular path, okay, and the object must have started from A, and if it takes one full round and comes back to A, then what happens? It has covered a distance, but still its displacement is zero. I also gave you an example that if it's a square object, okay, any path, you start from a point and you come back to the same point. You have traveled a certain distance, but displacement is zero. Is that point clear? So any diagram you can show, it's not necessarily circular, it can be a triangular path, it can be a square path, whichever path, but where you start from a particular point and then you end up at the same point, then displacement will be zero. Okay. The second question which is given over here is, a farmer moves along the boundary of a square field. So there is a square field whose boundary's side is 10 meter. Means one side is 10 meter. So all the four sides together will be 40 meter. So the farmer is moving along this boundary in 40 seconds. What will be the displacement at the end of 2 minutes and 20 seconds from the initial position? So we'll have to have a figure over here. This is a square field which we have considered ABCD. The farmer, let us assume, has started from the point A. The field is 10 meter side. So he starts from here and he takes one full round of the field. Okay, from A back to A, he's completing in 40 seconds. So then he is moving how much time? He is moving for 2 minutes and 20 seconds. So what is 2 minutes and 20 seconds? It is 120 second and 20 second together, 140 seconds. So in 40 seconds, he is able to complete one round. Am I right? The 40 meter perimeter of the field, because 10 meter is one side, so 40 meter will be the perimeter of the square field. This 40 meter he is covering in 40 seconds. One round he is making. So in 140 seconds, he will be completing how many rounds? 3.5 rounds, because 140 by 40 will be 3.5 rounds. Now 3.5 means from A, this is one round, this is second round, and this is third round. Now for the fourth round, it is half. That means the farmer will come at point C. So if A is starting point, then he will come at C if you are moving in a clockwise direction. If it is anti-clockwise direction, then also if A is starting, the person will come at C only. Is that point clear? So you have to find this displacement AC. Now a square will have all the four corners right angle. So this will be a right angle triangle. So Pythagoras can be made use of. Remember, I explained Pythagoras in the chapter 1 of maths, wherein we were taking the point 4.3 or 9.3 on the number line. Okay, so that Pythagoras is utilized over here. The triangle is ABC, so AC square is AB square plus BC square. So here AC square is AB square plus BC square. Both the sides are 10 each, so 10 square will be 100 plus 100, 200. So AC square will be 200 is written as 2 into 100. So AC square root will be 100 square root is 10, but 2 is not possible, so it will be root 2. So 10 root 2 will be the displacement of the farmer. Is that point clear? The third question which is given over there is, which of the following is true for displacement? Displacement cannot be zero. Is it true? False. If the person starts from a point and comes back to the same point, the displacement will be zero. So it's a false statement. Then magnitude of displacement is greater than distance. Is it true? No, again. Because distance is total path traveled, displacement is always the shortest distance. So displacement can never be greater than distance. So this will also be a false statement. So you'll complete these 3 questions in your fair book. Means your science notebook, you will write it down. Is that point clear? Okay. Today we continue further now with the type of motion. A motion can be uniform as well as non-uniform. Now what is uniform and non-uniform? Uniform means where it is systematic. Okay. Very systematic. All the means in a motion, when you are describing motion, what is very important? You should know the distances as well as the timing. So if the distance and timing are equal, then you call that type of motion to be uniform. Otherwise, the motion would be non-uniform. Example, this particular table if you see, distance traveled by a body A and a body B. 9:30 the body A starts, he's covering 10 meter. 9:45 is covering 20 meter. 10 o'clock 3:30 meter. 10:15 40 meter, like that. Means at every 15 minutes timing, duration of 15 minutes, the person is covering 10 meter distance. But the person who is B, traveling by the path B, there you find that at 9:30 12 meters covered, but 9:45 19 meter. Then 10 o'clock 23 meter and 10:15 35 meter. You find that though the time interval is the same, the distance covered is not in the same difference. So therefore, this is a non-uniform motion. Here you find that equal distances are covered in equal interval of time, so it will be uniform motion. Whereas here equal distances are not covered in equal interval of time. So it is non-uniform motion. Clear? So definition of uniform motion would be, if an object covers equal distances in equal interval of time, it is said to be uniform motion. So for non-uniform, you have to just add the word not over here. If an object does not cover equal distances in equal interval of time, it is said to be non-uniform motion. Clear? Okay. So now, once you understood uniform and non-uniform motion, and when the objects are moving, you will find that different objects will move at different timings. Isn't it? Different distances, different timings are there. So, how are you going to find out which particular object is moving faster? For example, there are many trains which are running on the rails, isn't it? In Indian Railways, there are so many trains. And all are covering different distances, their starting time is different, isn't it? So, how is it that you are able to say a particular train is fastest and another train is slowest? On what basis are you saying that? So, there should be a physical quantity which is able to measure which is moving fast and which is moving slow. This particular quantity that measures the rate of motion is said to be the speed. Speed is defined as the distance traveled by the object in unit time. This is the definition of speed. Distance traveled by the object in unit time. In a given time, how much distance is traveled by an object, that is the speed. Its unit is meter per second, because distance is measured in meter and timing is measured in seconds. So, distance upon time will be meter per second. The greater unit will be kilometer per hour and still smaller unit will be centimeter per second. But usually we consider meter per second as a common unit. Clear? Now, this is about the speed. But many a times you find that when you say a train is traveling at say 240 km per hour, does it mean that it is throughout from the start till the end it is moving at 240 km per hour? That is not possible, because when it starts from a platform, when it leaves the platform, it has started very slowly. Then it picks up gradually. Then it moves at a particular speed. Then again when it is approaching another platform, it will slow down. Isn't it? So therefore, here the speed, when you say that a train is moving at a so and so speed, it means they are talking about the average speed. So what does an average speed stand for? Speed is distance upon time, but normally when we talk about speed of any person, any object which is moving, it is generally the average speed. Average speed stands for total distance which has been travelled upon total time taken. So if you designate the distance as s and timing as small t, and then the average speed is given by a letter v, small v. So V is equal to S by T is the first formula of physics that you come across this year. 9th standard physics, first formula that you are coming across is V is equal to S upon T. So from this three physical quantity, you can find out whatever is missing. For example, if I want to find out s, that is the distance, then it will be v into t, that is speed into time. And if I want to find out time, it will be distance upon speed. Is that point clear? All the three is one and the same. So this is your first formula. Average speed is total distance upon total time. At the same time, if we talk about direction, if the speed is measured with direction, here you find that the distance traveled, but in which direction, that is not given. So here distance is there, we are not talking about displacement. But in this particular case, we talk about displacement, means the direction is important. That quantity is called velocity. It is the speed in a definite direction. Or still better, you can say that it is displacement in a given time. Velocity is measurement of displacement in a given time. Clear? And hence, you can be asked a 2-mark question, difference between speed and velocity. Speed, the definition is distance traveled by an object in unit time. Velocity, it is the speed in definite direction. So, second point of difference will be speed is a scalar quantity. Remember, previous video I told you distance is a scalar quantity and displacement is vector. So here speed will be a scalar quantity and velocity will be a vector quantity because here direction is involved. But units of both of them will be the same. Here also it is measured in meter per second, velocity also meter per second. Is that point clear? So the velocity of an object will change if the speed changes or if the direction changes. Is that point clear? A speed may be constant for an object, but the moment it turns, then its direction has changed, so the velocity changes. So sometimes a question is asked, when an object is moving at a uniform speed in a circular path, is it moving at uniform velocity? Like that a question might be asked. Okay, I repeat my question. If an object is moving in a circular path at uniform speed, will it move at uniform velocity? You might be asked to discuss this point. So you will say that an object may move with a uniform speed in the circular path. But since the direction keeps on changing, the velocity is not constant. Is that point clear or not? So velocity will change the moment the direction changes or the speed changes or both the direction and the speed changes. Clear or not? Okay. So now we take up. In the same way, just as you had average speed, you will have average velocity. But for average velocity, the formula would be the initial and the final velocities you take up and divide by 2. It means it is the average means sum of the velocities divided by 2. Mathematically, it's a mean. Mean of the velocities you can say. So U stands for initial velocity, V stands for the final velocity, and sum of them divided by 2 will be the average velocity. Is this clear till here? Okay. So now we'll take up calculative sums. In your textbook, you have been given the very first question. Example. An object is traveling 16 meter in 4 seconds and another 16 meter in 2 seconds. What is the average speed? So, average speed is equal to what did I tell you just now? Yeah, total distance upon total time. So, how should you work out this? Total distance upon total time? Here, this is how you work it out. You will say that the total distance will be, first is 16 meter, second time again he is moving 16 meter, so together it will be 32 meter. Timing, first he is covering in 4 seconds, second is covering in 2 seconds, so total 6 seconds. So 32 meter he is covering in 6 seconds. So therefore average speed will be 32 upon 6 comes to approximately 5.3 recurring meter per second. Clear or not? Understood till here? So this is how the sum on speed is asked. So speed and velocity point I hope is very clear to you. So you will have blue questions over here again on page number 102. So these are also to be written down in your notebooks. The first question I already discussed with you, difference between speed and velocity. Speed definition is distance traveled in a given time. Velocity is speed in a definite direction. Speed is a scalar quantity, velocity is a vector quantity. Clear? Now, under what condition will the magnitude of average velocity be equal to average speed? When is average velocity and average speed equal? You will find that these two are equal if the distance and displacement is the same. Means if the distance covered and the displacement covered are one and the same, total distance and total displacement, if it is same, then you can say that average velocity and average speed is one and the same. Now what does the odometer measure? This in the previous video I told you, odometer gives you an idea about the distance which you have traveled on your vehicle. You must have seen the digits changing as you move from one point to the other point. That is called the odometer. The speedometer measures the speed, I told you. Now what does the path of an object look like when it is in a uniform motion? When an object is moving in a uniform motion, it will always be a straight path. Because uniform motion, I told you, is within equal interval of time, equal distance should be covered, and that is possible only on a straight path, and that to a clear road. The moment the roads are having turns, you cannot expect a uniform motion to be there. Clear? Okay. Now the fifth one is a calculative sum. During an experiment, a signal from a spaceship is sent which reaches the ground station in 5 minutes. Means from the spaceship they are sending a signal which is reaching the station. The station is on the ground. That in 5 minutes it is reaching. What was the distance of the spaceship from the ground station? If the signal travels at the speed of 3 into 10 raised to 8 meter per second. So the speed of the signal is given to you, which is equal to speed of light. And timing is given to you. You have to calculate the distance. So how should you work out the sum? I told you only one formula for physics you have come across till now. So let us try to find out. The speed is given 3 into 10 raised to 8 meter per second. Timing is given 5 minutes. 5 minutes means you'll have to convert it into second. Why do you convert it into second? Because the unit of speed is in seconds given. So timing 5 minutes will be 300 seconds. So what will be the distance? Formula is speed is distance upon time. So distance will be speed into time, I told you. So speed into time you multiply. 3 into 10 raised to 8 is multiplied by 300. 3 3s are 9. Now this 100 part means 10 square. 10 square and 10 raised to 8 rational indices. Remember primary classes? So 10 raised to 8 and 10 raised to 2, if you multiply, it will become 10 raised to 10. The powers are added up. So finally 9 into 10 raised to 10 meter will be the distance of the spaceship from the ground station when it has sent the signal. Clear? Okay. Now we are having 2 more examples over here. Let us take up that example and then we'll wind up. The odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. Means kitna distance cover hua? Yeah, 2400 minus 2000 is 400 km. And the time taken for the trip is 8 hours. You have to calculate the average speed in km per hour as well as meter per second. Both the units you have to calculate. This is km per hour given in the sum. Therefore, first you will calculate in km per hour. So 400 upon 8. Why 400 upon 8? Because distance traveled is 400 and timing is 8 hours. So 400 upon 8 will come to 50 km per hour. Am I right? Now this km per hour you have to convert into meter per second. Now instead of converting kilometer by multiplying by 1000 and hour by multiplying by 3600, you can directly utilize the ratio of 5 by 18. Is that clear? Because 1000 upon 3600 is 5 by 18. So the value which you got 50, that 50 you multiply by 5 by 18, you will get the answer in meter per second. Okay, in your textbook it has been solved. This is 50 km per hour, but the other part has been solved by converting 1000 and 3600. So see, 2 5s are 10, 2 18s are 36. So 5 by 18 I told you. So 50 directly multiplied by 5 by 18, it will be converted into 13.9 meter per second. Understood? Okay, the last sum over here. Usha is swimming a 90 meter long pool. She covers 180 meter in 1 minute. 180 meter cover karna ho, 90 meter long pool means she went and returned back to and fro. And she is coming back along the same straight path. Find the average speed as well as average velocity for Usha. Now see, Usha is traveling distance how much? One part she is traveling 90 meter and she is returning again 90 meter. So total distance traveled is 180 meter. And this is covered in how much time it is given? 1 minute. 1 minute stands for 60 seconds. Clear till here? Okay. So if I want to find out her speed, average speed is equal to what? Distance, total distance upon total time. You have to write the formula first, then substitute the value. So 180 upon 60 will come to how much? 3 meter per second, correct? But what will be average velocity? Average velocity is given by total displacement upon total time. अब total displacement में क्या हो रहा है? The person starts from one end, reaches the other end of the pool and then returns back. है ना? Because it is 90 meter long pool. So from here she started swimming, reaches the other end, 90 meter हो गया. उसके बाद return back to the position. So what is the displacement? Displacement is 0. 0 upon 1 minute, that is 60 seconds, will be 0 meter per second. So average velocity is 0 meter per second, where its speed is 3 meter per second. Understood the sum? Okay. So we have done up till page number 102. You got an idea about what is speed, what is velocity, difference between them, sums related to that also I have taken up. So please see to it that the questions on 102 should be attempted in your notebook. Okay.